Hey guys, it's me back with Structures 2. Because that final is in, at least for my class, it's in like 4 days. The other section's in like 3 days. Uh, I went to that review today. I didn't really have any questions going in. I mainly went to see if anyone asked some questions that were like good questions that I wasn't thinking of. Um, but I did ask some questions. I wanted to still do these as like a helpful resource to go over material for myself and for to help others. So I wanted to start with the visual patterns homework because this is like the first thing we did in class one, and this is actually on the final. So essentially we're gonna have to draw the 100th term, draw the nth term, and write the expression for the nth term, just like what we did in the homework. So I just want to use the homework, go back and review it, starting with problem number one. So we got four figures here. Seems like we got 2 boxes, 4 boxes, 6 boxes, and 8 boxes. Now, there's all different ways to look at these problems. The way I do it might not be the way that you do it. So that is very important to note. So I am actually going to use another color here. Blue green. I like green. And let's just zoom it in. Right. So I'm seeing, oh, that's my eraser. Here we got like 2, right? And then here we got 4. So like here's this 2. And I guess we'll use blue. Yeah, we'll use blue. And then this is new. This is new. Same thing here, right? Here's our 2. This, and this. This is all new. Even figure 4. I'm seeing the 2 here, and I'm seeing that this is all being added onto it. All right? I did that very sloppily on my last one. I don't know why. I gotta lock in. Here, we'll do this. These are new. All right, bang. And then where's my green? That's our 2. So that's how I personally see it. So let me get this out of the way. So I'm kind of like the way I'm looking at it. It's like this is kind of like the base, and then it's like expanding outwards. You know. So that's how I would treat it. So like if I had to draw a fifth figure, my 2 is definitely going to be there. So it looks like I'm thinking of this as like because like they're also it only is expanding like 2 more blocks like in rows like that. It's not going higher. It's not going lower. So when I'm looking at it, I'll imagine this is like row 0 for this problem, and then here we have 0 and 1, 0, 1, and 2, 0, 1, 2, and 3, right? So if I had to draw a fifth figure, so this would be like my 0th row. 1, 2. Why are they getting bigger? 3. Said something, and they got even larger. And 4. So then total, just counting the blocks, here we have 2, 4, 6, 8. Here we have 10. So you can kind of start to see a pattern forming. So, looking at this, how many boxes are being added each time? Well, in our first time, we have just 2. In our second time, we have 4. So here is a +2 increase. Then we have 4, and then we have 6. So it's another +2. 6 and 8 is another +2. So it seems that our common difference, I'll abbreviate this CD. Maybe we'll do like a capital CD so it doesn't look like I'm like multiplying variables or something. CD, common difference, equals, we'll do +2. Yay. So going through that, looking at all that, right? Examining that. I gotta move on. Oh my God. Draw the 100th term. So kind of just going with what I just did to draw like a little 5th term as an example. Drawing the 100th term. Now I'm not gonna draw it all out and do all the boxes. That's a lot. So I'm gonna draw a giant box here. And I could do this, and these are both 1. And then the other, it would be 99 rows. Because if it's the 100th term, and if I count this as row 0, then these are going to be rows 1 to 99. Or if I counted this as row 1 and then 1, 2, 1, 2, 3, then this would be row 1 and these would be rows 2 to 100. Either way, there's 99 rows that would be like these, and then the boxes. Or you can kind of just look at what we got going on here. So the first figure, we have 2 boxes. Okay, so figure number 1 is 2 boxes. Figure number 2 has 4 boxes. Figure number 3 has 6 boxes. So it seems to me that we take figure number, multiply it by 2, equals boxes. Wowza. Okay, so that's pretty cool. Applying that to said 100th term figure, easy way for this problem, bing, bang, 200. Because if it's the 100th figure and we're multiplying it by 2, there's going to be 200 boxes that I am not drawing. It's a lot of work, man. Don't draw the 200 boxes. That's going to suck. That might take up your whole exam time. then you have no more time for the exam. Okay, so we kind of already did the nth term figure, but like in words. And that would be 2n. Because that's like what we were saying here. Like for the second figure, there's 4 boxes, which is like double the figure number. So 2 equals 4, and there's 4 boxes. Double the figure number, and there's 6 boxes. So if we don't know the figure number, if it's n and we do n plus n, It's going to be 2n. Or n times 2 is the same as 2n. So we have our little box. It says 2n. So then finally, we got to make an expression. So this one's actually the simplest one out of all three of these problems. Because we already did the expression. So the expression is 2n. Because there's nothing left over, essentially. Like, there's other examples, and we're going to go over them, where, like, you'll have your common difference, but then, like, there's still, like, one block changing. Or, like, there's, like, one block staying the same. Like, you could have a figure, and it could be, like, a block here in the center, and then you have block, 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 block right here. And that could be, like, figure 1. And then figure 2 is, like, this. Now, there's still these 5 boxes that were like in figure 1. But then now you also have this one and this one and this one and this one. So those were added. And these stayed the same. So then your expression would like have to reflect like, yeah, we're like multiplying, but we're also adding the stuff that like was still there. So pretty simple one to start off with. Just double the figure number. Now this one, I like this one. This one I don't mind this one. So we have our figure here. So I'm seeing, go back to my green. Seeing a little bit of that, right? This is like one option. Or we have that. Now I'm taking the green and I'm highlighting like the starting squares. So that's easier. And if you want, I think even Barton was saying this, if you want to like use another color to help you out with the visual pattern, go right ahead. Like she's not going to get mad at you for that. Like look at this. I feel that by doing this, it just made it 10 times easier. Because look, by highlighting with the green, the starting squares, you can clearly see where that is and then clearly see what's new. So 1, there's nothing. 2, you got bang, bang, and bang. 3, here, here, and here. 4, here, here, and here. This one too. Right? So I actually think I did it differently when I originally did the homework. But this was like one way. I think what I did on the homework was isolate this and did the professor's strategy where you find like the 1, you find the 2, like in the problem. So like you find the 1. Here it is. There's 1, 1, and 1. You find the 2. 2, 2, and 2. You find the 3. All right, and so forth. So this would be the 4. So this is another way to look at it. Okay, so let's take a look at both, actually, for drawing the 100th figure. All right, that's what this first box is, drawing the 100th term. So if we do like this, the way I have it on the homework Okay, now that I'm actually like looking at it, I thought of it two different ways. Because I thought of it the first way on the visual patterns, but then I thought about it this way when doing the math, which is a little odd, but it's whatever, I guess. Um, so this way, let's put a line there, make the line better. Um, so we're gonna have our block, and that's one. And then here we have 1, 1, and 1 branching for the first figure. For figure number 2, we have 2, 2, and 2 branching. Figure number 3, we have 3, 3, and 3 branching. Figure number 4, we have 4, 4, and 4 branching. So figure number 100, we're going to have 100, 100, and 100 branching. So that's one way. The other way is if we do what we had first and highlight out the, oh my God, highlight out the whole thing. The whole thing. So that's 4, right? So then if we do that for the 100th figure, we're going to have, our boxes here, right? And each of these are 1. And then let's look. So on figure number 1, we have nothing. We have no branches. Assuming that the green is the one staying put, anything outside of the green would be like a branch, right? So on figure number 1, we have 0. Figure number 2, we have 1, 1, and 1. On number 3, 2, 2, and 2. On number 4, 3, 3, and 3. So on figure number 100, seems like we're subtracting 1. So here is 99. Here is 99. Here is 99. So that's two different ways to draw it, two different ways to think about it. If you look at just this middle square here as your 1 and the rest is the branch, then for 100 figure, that's going to be your 1 and the branches are going to each be 100. If you look at the whole thing as the whatever staying, as all 4, then all 4 are going to be your 1s and each branch is going to be 99 to reflect the fact that you included these other 3 that weren't just that middle square. So, continuing on with this, the nth figure for our top problem, so looking at the 100th figure for method 1, each branch in the 100th figure is 100. So, for the nth figure, this is still going to be 1. We need a number there. That's 1. That stays. And then each branch is the same as the figure number. So each branch is n. For method 2, if we need our 4, right? 1, 1, 1, and 1. We need our numbers. And then each branch, so like looking at this one, each branch in the 100th figure was 99. So it seems like for the figure number, the branches are one less than that. So if the figure number is n, each branch is going to be n minus 1. This kind of looks like really bad on on the iPad. Yikes. Oh well. I'm sorry. So now we're going to end up with the same answer for the equation, no matter what. But with our two methods, we're going to get to said equation a little differently. Or expression. I lied. They're not equations. There's no equal sign. That's really important. Expression does not have an equal sign. Sorry about that. Okay. So for the first method, we count out our n's. We have 3 n's, and we have a 1. So plus 1. For number 2, that's it. Number 1 is there's 3 n's and then there's 1. So it's 3n plus 1. Number 2, we have n minus 1. We have 3 of those. Actually, I'm gonna put a 3. So I know how to factor. So we have 3 n minus 1s. Plus we have 4 1s, which is just 4. So right now our equations are looking a little different. This one is simplified. This one is not. On number 2, this one is not simplified. So we have 3 times the quantity of n minus 1 plus 4. So if we distribute the 3 into the parentheses, we're left with 3n minus 3 plus that 4. Now, the 3n, we're good. Nothing else we can do there. But this, negative 3 plus 4, can be simplified to positive 1. So then, yes, we are left with 3n plus 1. So our answer is 3n plus 1. Hooray! Okay, well, last one. Last visual pattern one. We got this funny looking shape. Low key, right? It looks like a spaceship. It would be kind of cool. I don't know, man. I kind of see a spaceship. Let me know, twin. I gotta make myself laugh so I don't go insane. Happy spring semester. Anyway, so. Oh, I didn't even write our common difference. Oh my god, I cannot believe that. We didn't even look at the number of squares. So number 1, there's 4 squares. Number 2, we have our 4. And it looks like we're adding 3. So we have 7. Number 3, we have our 4. 5, 6, 7, 8, 9, 10. So it looks like we added 3 again. And then here we have 3, 6, 9 plus our 4 is 13. So it looks like we added 3 again. So our common difference is equal to positive 3. Now, you could just put 3, like you could put common difference equals 3. I just like to put the positive 3 as just like a little reminder that it is increasing. Because say if this was figure 1 and this was figure 2, that's not usually going to happen, at least with the visual patterns. But definitely remember, like with the sequences, Will it let me back out of this? I don't know if one of these are an example of it, but you have like a sequence like this of numbers. They could be decreasing. Like you could have started with like 46 and then 39, 32. They could be decreasing. So then your common difference will be like a negative number instead of a positive number, you know? So I like to put the positive for that reason back here. Oh, thank God. I didn't know if it was going to save my work. So back to the spaceships. So the way I'm looking at it, right? Again, two different ways. I don't think I'm going to do both ways for this problem because these figures are huge and I don't want to do that. But I'll still point them out. I just won't do like the two methods for the rest. So one way to looking at it, you have these, and then you have your branches. So for figure number one, we have 1, 1, 1, and 1. Figure number two, we have our 2 in the middle. And then we have 2, 2, 2, and 2. Now, the other way of looking at it, and like so forth and so forth. So, like, we have our 2, and then our 3, 3, 3, and 3. We have our 2, we have our 4, 4, 4, and 4. So, another way of looking at it would be like this whole thing is what's present. So then, like in up here, figure number 1 would have no branches. Figure number 2 would have 4 branches, each of like 1. So in 2, it'd be 1, 1, 1, 1. In 3, it'd be 2, 2, 2, 2. Now, I think I did the easier one, in my opinion. This was like a little more challenging. But if you see it this way, props to you. Like, you're locked in. Now, the way I did it on the homework was the 2, and then the 1, 1, 1, 1, and then the 2, 2, 2, 2, 2, the 2, 3, 3, 3, 3, and so forth. That's how I did it. So I think for the purposes of this, I'm going to mix it up, and I'm going to do this way. But we're still going to get the same answer. So on figure 4, I'll highlight this here. Bang. And then we have 3, 3, 3, and 3. Okay, so finding our 100th figure, what we have 1, 2, 6. We have 6. So we have our, let me move this. We have our 2 in the middle. Then we have like 1 here, 1 here, 1 here, 1 here. And these are each 1. And then it seems like for the first branch we have 0. For the first figure we have no branches whatsoever. We have no extra box. For the second one we have like, so it's each branching like here, 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 and here. And each of those branches have 1 less block than the figure number. So I'm going to sneeze. Maybe I'm not. Okay. So here we have figure 2. We have 1, we have 1, we have 1, and we have 1. So for the 100th figure, each of those branches are going to be 1 less than the figure number. So each branch is going to be 99. So this one is 99. 99. Oh. 99. 99. All right. So that would be our 100th figure. Going off of this, using the same visual, our nth figure, if we keep these 6 blocks and our 4 branches, then each branch would be 1 less than the figure number. So n minus 1. So then with this, we can find our equation. We have 1, 2, 3, 4 of the n minus 1s. And then we have 6 ones, so it's just plus 6. And this is not simplified, so we have to do that. So we're going to distribute the 4 into the parentheses. So we have 4n minus 4 plus 6 minus negative 4 plus 6 is positive 2. So we are left with 4n plus 2. Just to double check our answers, for number 1, we should have gotten 2n, which we did. Number 2, we should have gotten 3n plus 1, which we did twice. And number 3, we should have gotten 4n plus 2, which we just did. So here is there's nothing on the second page, yeah. I don't know why there's a second page. So here's just a quick glance of the whole sheet. Let me zoom in a little. There we go. I'll hold it there. Oh, hold on. I almost forgot the common difference again. C, D, bang. So, looks like here, we have our figure. And then here, each of our branches are 1, and there's 4 branches, so it looks like a plus 4. Because there's 6, 7, 8, 9, 10. 6, for number 3, 6, 7, 8, 9, 10, 11, 12. So it looks like another plus 4. For number 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And this was 14, I think. 6, 7, yeah. So plus 4. So our common difference is positive 4. Okay, so now for real this time, a glance at everything. Thank you so much for using this as a study resource, and happy studying. See you.